Good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
The Honorable Dean of the Faculty of Agriculture, Universitas Gadjah Mada, Professor Insinyur Jaka Widada, MP PhD, is delegated by Professor Subejo, S.Pi, M.Sc, PhD. The Honorable Head of the Department of Fisheries, Faculty of Agriculture, Universitas Gadjah Mada, Profesor Dr. Insinyur Alim Isnan Setio, M.Sc. The Honorable Speakers, Dr. Thuy and Dr. Natural Science, Faizal Rachman, S.Pi, M.Sc, and all the distinguished audience. It is an honor to welcome you to the 33 SinnTech webinar. Let us begin expressing our sincere gratitude for the opportunity to gather today and share knowledge in this international forum. My name is Ilma Azizah Arfiani, and I will serve as the Master of Ceremony for today's event. I will guide you through the SinnTech 33 webinar with the Integrated Coastal Management. We will now proceed for the first agenda, the opening remarks, which will be delivered by the Dean of the Faculty of Agriculture, is delegated by Professor Subejo, S.Pi, M.Sc, PhD. To Mr. Subejo, the time is yours.
Okay, thank you. It is clear, my sound?
Yeah,
Clear enough?
clear, bro.
Okay, thank you. Yeah, on behalf of Faculty of Agriculture, we firstly highly appreciate to Dr. Ngo Chui Hao from Xiamen University for giving the very important topic for afternoon webinar, and then for Dr. Faizal Rahman from Department of Fisheries, Faculty of Agriculture, Universitas Gadjah Mada. We truly highly appreciate for this chance, and we do believe through this afternoon webinars, I think we could learn many idea on the coastal management, on fisheries management, and so on. So I think this is not only scientific exchange, but this is also about the networking and then exchanging the idea, exchanging the experience, and exchanging the policy on the issue of integrated coastal management. And on behalf of Faculty of Agriculture, we also highly appreciate to Department of Fisheries. I think this is already 33rd round. Yeah, highly appreciate. Started from the COVID-19 era and then still continue, maybe almost every month. And we really highly appreciate for this continuous webinar, and then also invite so many people from various institutions, not only from Indonesia, but also from overseas institution. So we do believe that through this kind of webinar, we could exchange so many information, especially related to the issue on fisheries, on the maritime, and also on the coastal management. And yeah, formally, we open this 33rd SinnTech webinar this afternoon. We do hope that webinar will be success and very useful for all of us. Thank you very much.
Thank you very much to Professor Subejo for your insightful and encouraging remarks. Ladies and gentlemen, next we will be proceed to the national anthem of Indonesia, Indonesia Raya, followed by Okay, thank you for the operator. We will now move to the main session of today's webinar. The session will be moderated by Mr. Tony Budisatrio, S.Pi, M.Sc, PhD. To, to Mr. Tony Budisatrio, S.Pi, M.Sc, PhD, the time is yours.
Thank you for the nice introduction. Good afternoon, everyone, and welcome to the SinnTech webinar organized by Department of Fisheries, Gadjah Mada University. And it's a pleasure to have all of you joining us in this SinnTech webinar session. We are excited to have participants from different places. So just feel free to share your location in the chat. Okay. Yeah, my name is Tony, your moderator for this webinar. And today, our webinar topic is integrated coastal management. This will be an interesting discussion topics as integrated coastal management aims to balance environmental protection, economic development, and also social needs in coastal zones. To discuss further about our interesting topic today, we already invited two speakers. The first one is Dr. Hao from Xiamen University in China. And our second invited speaker is Dr. Faizal Rachman from Department of Fisheries, Gadjah Mada University. Just quick overview in this webinar, the invited speaker will be delivering the presentation around 30 up to 40 minutes. And following the presentation, there will be a Q&A session. We will appreciate if the participants engage in the Q&A sessions. You can use Zoom chat to write down your question, and direct question through open mic is also preferable. So before we start the webinar, let me introduce briefly our first invited speaker, Dr. Hao. Dr. Hao holds a master and doctoral degree from Xiamen University in China. Her expertise including geospatial analysis with quantum GIS and RStudio, and then carbon cycle modeling, biodiversity assessment. And today, she is going to give a talk about spatial mapping of cumulative human impacts on mangroves in Southeast Asia. Let me greet Dr. Hao. Hello, Dr. Hao. How are you?
Hello, Professor Tony. I'm here.
Yeah, okay. Yeah, welcome to our SinnTech webinar series.
Yeah, thank you. Thank you, Professor Tony, for for the introduction.
Yeah. Are you ready to start the talk?
Yeah, sure.
Yeah. Well, without further ado, I will hand over this session to our first invited speaker, Dr. Hao. You have 30 up to 40 minutes for delivering the presentation. And yeah, Dr. Hao, the floor is yours.
Thank you, Professor Tony. So I'm gonna share my screen. Okay. Okay, so good afternoon, everyone, distinguished professors and all participants. First of all, I would like to thank Department of Fisheries and University of Gadjah Mada for inviting me to participating in this event and shared my research. My name is Thao from Vietnam, and I recently graduated from Xiamen University, major in environmental management. And my research center around mangrove ecosystem management. So today I will present my work titled Spatial Mapping of Cumulative Human Impact on Southeast Asian Mangroves. So this work is part of my doctoral study at Xiamen University, and the results of this finding, the results and the findings of this research have recently been published in Global Change Biology. So in more details of the research and the results of finding the methodology, you can refer to this published article. So in today's presentation, I will present some of the main findings of my research regarding the regarding the impact of human activities on mangroves in Southeast Asia. Okay, so first, regarding the practical rationale, Southeast Asia is one of the world's densely populated region, and it has some of the world's largest mangrove areas. But this region is also experiencing significant loss due to human-driven changes, as you can see on the right, the first finger on the right here, from FAO 2023. So in Asia, the loss of mangroves is driven mostly by human activities. So we need a comprehensive picture for the exact impact of human on mangrove in this area to have anticipatory actions regarding managing the mangrove ecosystem. And so we need to know the relationship between the stress from human activities and this ecosystem to have the effective integrated management and policy actions. And we also know how to prioritize the efforts among many, many different areas. So how to prioritize the efforts to tackle the dominant among these threats from human activities. So, and besides integrating human dimensions into ecological model is also identified as a research priority under the UN Ocean Decade. So this leads to the first practical question of what is the extent and how mangrove ecosystems in Southeast Asia are affected by human activities. And from the theoretical side, actually, mapping cumulative human impacts has quite a long history. It developed from the qualitative mapping to quantitative and global scale assessment like global and human footprint, and etc. And until 2008, when the standardized spatial cumulative human impact by Harper and colleagues, it has been widely used across scales and across ecosystem around the world. However, there are several limitations in that traditional and widely applied CHI cumulative human impact. So, for example, it assumes that the expert surveys, the results from expert survey are totally accurate. The results from the sensitivity, weight, and decay distances. So these parameters I will explain later in the methodology. So in the traditional assessment, they assume the total accuracy of these parameters, and they do not consider for some potential ecological dynamics like potential stressor interaction or spatial dependency of the stress from human. And regarding the stressor interaction, there are many studies has been published on stressor interactions. However, they are mostly investigated via experiments, field observations, and meta-analysis. So they have the limitations in the replication and difficult to generalize because they are context dependent. And furthermore, these methods often emphasize the pairwise interactions. And so they cannot capture the full complexity of the ecological dynamics because stressor interactions can happen in high order. It's not just pairwise. So and besides these existing studies, they focus mostly on identifying and classifying stressor interaction. Whether they are synergistic or antagonistic, rather than predicting their combined effect. So this leads to the main theoretical question in my research, which is how to take into account these unknown processes, these limitations into the traditional mapping cumulative human impact. So that is the framework of my study. So I will to simplify it. So as you can see on this slide, it actually basically have three major components. So firstly, I will set up the new model that integrate the unknowns into the impact assessment. And then second is to formulate the list of human stressor, the human activities that are typical, that reflect the typical human activities that affect mangroves in Southeast Asia, and extract the expert opinions on the sensitivity, weight, and distance decays to finally produce the findings on the impact of human activities on Southeast Asia. So I will go into detail for each of these components in the following slides. So firstly, regarding the input data component, so after the literature review with certain criteria, we have a list of 20 stressor human activities in Southeast Asia and the corresponding stressor. And that is the expert survey forms. So in this survey, I will ask the experts on two parameters. The first one is the sensitivity weights, which means how vulnerable the mangroves is regarding that stressor. And the second parameter is the maximum effect distance. So it means like what is the maximum effect that the stressor can have on mangroves. For example, something like a plastic landfill, for example, landfill. So it will not just have the effect directly in that point, but it effect can extend further in further distance for nearby mangroves. So I also consider the maximum effect distance in my spatial mapping for the human stressor. So, and then after having the input data here, I will put into my model. So my model, that is the traditional CHI. In the traditional CHI, this can simply understood as adding all the stressor together in each grid. So in a map, I will divide it into grid of 1 kilometers, grid cell of 1 kilometer. And then in the traditional CHI, they will just adding up all the stressor together. And then and here the formula for calculating for each grid is like for one stressor is like the the uh, the present data of the ecosystem grid, whether it has mangrove or not. So when it has mangrove, so it is 1, and no mangroves, it is 0. So this is binary. And then the second is sensitivity weight. This one is from expert surveys. So this one is for the vulnerability that mangrove is for that stressor. And another one is the stressor intensity. So this one is the data that I collect from here, from this list of stressor, and then I collect the secondary data for all of these to have the intensity for each of these stressors. So, and then I will calculate for each grid in the map. And the problem is, and then the maximum distance decays is calculated by the exponential decay formula. So the problem with the traditional CHI is that they treat everything as fully known variable, and they assume that the stressor act in the additive way. But in my model, I will change a little bit. I would not treat these variables as the known variables, but I treat as the unknown variable under the Bayes framework. So when after I have the data from the expert survey, I would not just take the mean of the data, but use it as the prior under the base framework. And then I also incorporate this variability variable. This reflects the potential stressor, some additive, some synergistic, some antagonistic effects that can have on the mangrove in that grid. And that is for more details for the how I calculate the maximum effect distance and sensitivity weights from the expert surveys. So because expert can have different opinions and they cannot have the exact number in the exact true number. So someone can underestimate, someone can be overestimate. So that's why I model the input from the expert survey follow the normal distribution from the true value and around a certain variance around the true value. And then next, I will model these variants because this variant is needs to be strictly true. Needs to be strictly positive, and it's also can have like something skew, maybe like follow the skew distribution. So that's why I model it as follow the log normal distribution. And I will solve this model using this RSTEM package. I cannot solve it analytically because this one cannot be solved analytically. And I will use the MC sampling using RSTEM package. And then for the structural variability, so this one reflects the potential hidden ecological dynamics. For example, the stressor interactions or the spatial dependencies. Nearby locations can have similar effects rather than the distant locations. So that's why I will model this following the Gaussian processes. So similarly, I will solve this not analytically, but using a machine learning model, and I use the LAGP package in R. And then this is a result for my finding. So the first key result is that in Southeast Asia, only 18.6% of mangroves is identified as intact, and more than 80% identify as impacted by human activities. And critically, no intact mangrove areas are identified in Vietnam, Brunei, and Singapore. And second, this one shows the distribution of the values of the CHI scores. So we can see that although Southeast Asia are vastly impacted by human activities, but most of the countries have relatively low values. For example, Indonesia, Myanmar, Brunei, Cambodia, mostly just around 1. But in terms of other countries like Singapore, Thailand, and Vietnam, Philippines, it is much higher. So this is the second finding. Next one, this is the spatial map of the human impact in Southeast Asia, Southeast Asian mangrove. So we can see that some hotspots of CHI impact found in Gulf of Tonkin, Mekong Delta in Vietnam, here, Gulf of Thailand, and Java Island in Indonesia, and the Western Philippines and Peninsula in Malaysia. So here are the key hotspots that I found in my assessment. And I also have the maps for each of the country in more details here, for example. Yeah. And the next finding is that in Southeast, and then I will divide into individual stressor to see what is their contribution to the impact. So overall in Southeast Asia, aquaculture ponds stand out as the most significant contributor. And some other prominent stressor include road density, cropland, nutrient pollution, and urban area. And I also go into more details for the contribution of each stressor on each country for each country. So we see a clear distinction between some countries that are affected more by aquaculture and agriculture related stressor like Vietnam, Thailand, Philippines, Indonesia, and Cambodia, and some others that are rather more impacted by urban related stressor like Malaysia, Singapore, East Timor, Myanmar, and Brunei. So the other thing is that we from this figure we can see that most countries in Southeast Asia are impacted by just one or two dominant stressor. Like as you can see here, Vietnam, Thailand, mostly impacted by agricultural ponds, and Indonesia also agricultural ponds as well. Yeah, but the case is different for Singapore when it is impacted by many stressor, and Thailand as well here. Yeah, so some key insights from my research is that in Southeast Asia, although the intact mangrove areas are scarce, but most impacted areas remain under low human pressure. So this is both positive and negative and positive to some extent. So extensive areas of mangrove in Southeast Asia requires the need for intervention to protect the mangrove ecosystem in this area. And a notable finding from my study is that some countries like Brunei, Myanmar, Indonesia, Cambodia, East Timor, and Malaysia exhibit relatively low cumulative human impact. So these represent the areas where restoration and impact mitigation can still prevent into transition into irreversible degradation. And this the second insight is that in Southeast Asia, most countries are affected by one and two dominant stressors. So this one makes it easier for more targeted intervention. So countries with fewer dominant stressor may benefit from relatively straightforward intervention actions like agricultural zoning or sustainable agriculture. And some more complex contexts like Singapore and Thailand, which face different multiple simultaneous stressor, maybe they demand more complex responses and cross-sectoral responses. So besides in my studies, I also find an interesting case of Brunei. So previously, in around 1980s, Brunei's mangroves are heavily impacted by human activities. But in these studies, the results seems a little bit different when this country experienced quite low score. So other countries maybe future research and other countries we can take a look at the case of Brunei, how the policies and management actions have been regarding the protecting the mangrove in Brunei have been to maybe to learn and gain some insights from their intervention actions. And besides these studies, we highlight that different countries face different kind of stressor. However, maybe we need a kind of more collaborations on sharing the experience among the countries. Some country maybe they face similar problems. We can share our insights, our experience together, and some other countries maybe they have better lessons and better policy intervention pathway. We can also share the lesson to other countries, and we cooperate different mechanisms to promote the mangrove management in our area. And yeah, and besides, I think mangroves are heavily impacted by human activities in Southeast Asia. So this require the integrating the mangrove aspect into the coastal management, integrated coastal management, so that we can address different threats along with mangrove. We cannot just manage mangrove differently from other aspect and other human activity and industries. Yeah. So thank you very much for for listening to my presentation. And if you have any questions, I'm very willing to answer and discuss.
Yeah, excellent insight about the mangrove conservation, yeah, in Southeast Asia, and yeah, and also the interesting modeling study. Thank you very much, Dr. Hao.
Thank you, Professor.
Yeah. By the way, just call my name Tony. That's that's okay. I'm okay.
Oh,
Yeah. Yeah. Now let's open the floor for a Q&A session. And let me check. Oh, there is in the chat box, there is no question yet. And yeah, while waiting for a question from participant, yeah, maybe someone would like to raise hand. Any question?
Mas Tony, can I ask some question? One question, I mean, for
Yes,
how?
yes. Yes, go ahead.
Yes, how? After a long story and long journey with your PhD program progress, yes, it's quite interesting. I want to ask about the mangrove condition based on your model, especially in Java Island. You know, in Java Island is so many area that's impacted, right? Yeah, for the truth that in Java Island there are so many aquaculture pond. So why? Yeah, so why that's your results indicated that it was stressed by the aquaculture activity. Based on your models, what kind of parameters of stressor that you use in your model to define that the area or the mangrove is impacted by the situation by the aquaculture ponds? You are still mute.
okay, sorry. Okay, so here is the model. So basically, the model is it perform for each grid in the map. And
Okay.
then I will firstly collect the data on the here on agricultural ponds. So
Okay.
so so if the how to say here it requires three keys data. The first one is the intensity of the
Okay.
of the stressor. For example, aquaculture, if the aquaculture is identified in that place, so for example, it will define as one, for example,
Okay.
because it is present. And how mangrove is impacted by that is defined by the expert. So the expert will give opinions on how the stressor impact mangroves. So they will give a number based on, for example, 1, 2, 3, 4, 5, regarding different scales, regarding different grades that they can have on mangroves. For example, even this one is mangroves. This is aquaculture, and this one is plastic waste size. The
Okay.
the 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 score for each of these is different because the expert gives them the different vulnerability uh, towards this stressor. And then it is also calculated using the exponential decay. So I can draw on this one. For example, here we identify this one is the aquaculture ponds, and this one is mangrove. However, if mangrove is here, of course, we just calculate it directly as the stressor intensity plus the sensitivity weights and and the presence of mangrove and so we can just apply it directly. But for here, the this value will be different. So the stressor intensity here will be different and will be
Okay.
calculated in one more step by applying the exponential decay. Here maybe the effect is 5, but here maybe the effect is only about 0.5. So I will also calculate the impact for nearby mangroves as well, for nearby grid as well on mangroves.
Okay.
Yeah, and I apply the exponential decay. Yeah.
Okay,
Yeah,
nice.
outside of that grid. So if mangrove is inside that aquaculture, maybe it will have the value of the direct number from the expert survey. But if it is outside, the intensity will be different.
Okay.
Yeah.
Okay. So, it is possible if we adopt this model to the others like aspects, like identifying the effect of tourism, maybe.
Yeah,
Yeah.
sure.
Ah.
So for tourism side, we can also apply to this one. Actually, in my study, I also incorporate the tourism size as one of the stressor. I collected the data based on the OpenStreetMap. I collect all the
Okay.
tourism sites in Southeast Asia and also apply into this one. So this model can be applied to calculate the spatial impact of human activities or some other environmental stressor on ecosystem. Yeah.
Okay, nice. Thank you, Hao.
Yeah. Welcome, Faisal.
Yeah, thank you, Mas Faisal, for your question. Yeah, talking about the model, I just wondering if do you have some consideration factors in choosing the suitable model? As far as I know, that there are many models, and maybe I don't know if in your case, in your study, maybe this is only the appropriate model. So maybe do you have any opinion?
Yeah, I think from my side, working on modeling, ecological modeling, I think we model selection is based on our purpose. And for our purpose, actually there are different models to choose from. And in this case, which model to choose, it really depends on different factors. For example, your computing capacity. In this model, for example, it requires high performance computer to calculate the big data, to process the big data or large data processing. Without big data processing capacity, I mean the computer, this is not advisable. I think we should move back to the traditional one because it's just adding up everything together. But in my model, I will enhance it and use a base hierarchical modeling. So this model, we have some kind of purpose to address, some limitation to address. Base hierarchical model can address these concerns. However, base hierarchical model, for example, it has a weakness in being subjective in choosing the parameters. For example, when I choose it follow the log normal distribution, it's also my choice with my assumptions. So model is also from our assumption as well. Then when we want to choose the effective model for our model for our assessment, maybe we need to consider something like computer capacity, performance capacity, the assumptions that we want to have to put into the model. That is the key point. The assumptions and the thing that we want to model. It is just like model is just like even drawing. We drawing a picture. It is also a kind of model. So it depends on the tools that we have, and it also depends on how much in details, what is the things that we need to focus to decide the models that we should choose. Yeah.
Yeah. Okay. Yeah, I see. in the chat box, there are 2 questions. Maybe we can go with the first question. My name is Mulaye Kurubali, an international student at University of Brawijaya. Faculty of Fisheries and Marine Science. The question is, what role do you think can the local community play in reducing human pressure on mangrove?
Thank you, Mulay, for your question. I think this I can say that the local community plays a very important role. My research has its own function. Each of the stakeholder plays their own functions, and they should work together. From our side, as a scientist, as a researcher, maybe we can play a role as for example, this kind of impact assessment. It can have a role in informing the targeted actions. But actually, for the effective conservation and restoration, it depends a lot on the policy actions and the coordination with the local community. The local community is the key factor that decides. Because for example, when we want to implement the sustainable agriculture, it is not just our scientists say we recommend this way is good for the environment, for the mangroves. It's not just um, uh, the politicians. It's also about the policy, how and the practitioners. Maybe they will how to coordinate with the local community to implement that, how they can raise their knowledge in implementing that kind of sustainable activities. So overall, I think local community plays a key role, and we as the scientists and some policymakers, we should try to coordinate with them, and it will translate to the reality results. So that is my opinion.
Perfect, Dr. Hao. And there is another question from Ika. The question is, could you please advise how to check GHI mangrove to consider whether a coastal needed to be plant more mangrove due to the intact mangrove in this area cannot solve several problems such as erosion of shoreline and high tide or tsunami? I think this is more a practical question, right?
Due to the intact mangrove in this area cannot solve severe. This is a kind of practical question for policy maker, coastal planning, integrated coastal planning. In some intact mangrove areas, maybe we still need to protect them because of their high biodiversity support. They can play as a role for maybe not for shoreline erosion, maybe, but for other functions. And for the in some reasons that, and for planting or restoration, it really depends on the it is not just about human impact, but it's also about the ecological conditions as well. So when we have a purpose of protecting the erosion of shoreline, maybe we should investigate some important aspects such as the ecological suitability, and then we will try to revise the local actions regarding that restoration area. I mean, maybe there are some stressor nearby. We need to find a way to address them to minimize the impact. But on the other hand, the very important point is to consider the locations that is suitable for restoration in this area. Yeah, but for the intact area, I think we should still need to conserve them for some other purposes rather than beyond the erosion. For example, the biodiversity support for other species. Yeah.
Yeah, thank you, Dr. Hao, and thank for the answer, and thank you, Bu Ika. Bu Ika is from Marine and Fisheries Agency in Yogyakarta. Yeah, please, if there is any other question, just feel free. We still have a few minutes. Yeah, Dr. Hao, I just wondering, you have the figure which show the cumulative human impact. Yeah, how can we interpret the cumulative human impact? I mean, low score and high score. Yeah, I think you have it in the previous slide, maybe.
Yeah.
Yeah, this one. Yeah, maybe
Yeah.
this is interesting too.
And I would also want to share that because this one is applied, the expert survey parameters is applied across the ecosystem in Southeast Asia. So this one, the results of my finding is just about the stressor aspect. So the potential stressor pressure that human can have on the mangrove areas, but it's not reflect the health of mangrove. So these concepts are different. So the actual health, the actual conditions, it also depends on the policy actions from the country, from each country. For example, the aquaculture practice in Indonesia, for example, in this region is sustainable. So maybe the impact is different from other country, right? So my study here, the findings here, informs the potential stressor that we human activities can impose on mangrove. It's not about the resilience or it's not about the current condition health of the mangroves. So if we want to investigate the health, the current health, maybe we need to incorporate different aspect as well into the model. Yeah.
So does it mean that there are, for example, if there are many the huge mangrove area, it doesn't mean that the it's not health in a health condition.
I mean, this one is apply the score for intense the score for sensitivity weights is applied across the region, uniformly across the region. So it just reflects the potential pressure on the mangrove across the region in a uniform way. But actually, in reality, so this is one of my limitations. So in reality, mangroves area can respond differently, can be vulnerable in different degree of vulnerability to the stressor in different region. So maybe the future model can incorporate this consideration into their impact assessment. For example, young mangroves maybe they can respond differently to the long planted mangroves. So the impact assessment, when we consider this aspect, can be different. So maybe in the future, the model can consider this aspect into the modeling process. Maybe in here, maybe there are some researchers also related to this. So maybe you can consider this aspect. Yeah.
Okay, thank you, Hao. And I think we have one question. I think this the last question for you. Yeah, hello from Ika. From Ika, hello, Hao. I want to know if there is any case condition where mangroves are so abundant that they become invasive if the entire front line is planted with mangroves, or is it a good thing that it reduces since mangroves are major habitat for many aquatic species. Yeah.
So in here, I would want to divide it into different different cases. So the first case is, you mean the condition is that the natural conditions, right? The natural conditions that mangrove are so abundant. So it cannot be considered as invasive. It is like it is the current mangrove areas. I don't think so. It is not considered invasive, but if it is the planting mangroves, it can be considered. I mean the reintroduction or the replanting of replantation of mangroves, it can be considered invasive. So we need to be careful in terms of the introduced restoration. So I think this topic is my current presentation, but in my opinion, we need to divide it into whether it is reintroduction, replanting, or planting new. So these can have different kind of effects, and we should, and then for different kind of these cases, we should need to consider the invasive problems. But for the natural mangroves, I think no. For others, yeah, we should consider.
Okay, I see one chat, one another question. Is that okay for you? We have like less than 5 minutes. Yeah. The question is from Alagi Sohna. The question is, how can these anthropogenic activities be reduced since mangroves are a major habitat for many aquatic species and carbon restoration?
How can these anthropogenic activities be reduced for many aquatic? Since mangroves are a major habitat for many, how can these be reduced? Yeah, we can have some different. Of course we can have some kind of actions to reduce these anthropogenic activity. The very important thing is the policy action, the policy intervention capacity from the government, from the decision maker. I take one example from agriculture, for example, aquaculture, for example. In aquaculture, there are different practices for aquaculture. We can have some practice. In some region, their practice is very, how can I say, traditional, conservative, and maybe they can have big impact on the environment. But some other reasons, they have adopted the sustainable practice. Maybe they will try to find some ways to minimize the impact on the natural environment. But how to do so is not easy for the local people. So we can have some kind of training, some kind of how to say, intervention to persuade them following the new sustainable practices. So these are the example of how we can intervene to minimize the impact of human activity. And in some other cases, in terms of integrated coastal management, when we do the spatial planning, and we know that this area is heavily impacted by human activities, and which activity is the most dominant, we need to address that. And then we can have something like we can remove it or to other places, relocate it to other places, for example. But it's not easy. It really depends on the capacity of and the willingness of the local people with the decision maker. It is not an easy task. So that's why at the end of the presentation, I suggest that mangroves management should be integrated into the overall integrated coastal management. Yeah, to coordinate different kind of industries and activities take consideration altogether.
Yeah, perfect, Dr. Hao. Thank you for those thoughtful answers. And yeah, because our time is limited and we have to end the session with the first speaker. And let's continue to our second invited speaker, Dr. Faizal Rachman. Before I hand over to our second speaker to get started, let me introduce him briefly. Yeah, Dr. Faizal Rachman finished his bachelor and master studies from Gadjah Mada University. Then he got a scholarship and continue his doctoral studies in Coastal and Ocean Management Institute in Xiamen University in China. And now he is affiliated with Department of Fisheries, University of Gadjah Mada, and his research is focused on GIS in fisheries management. And today in this webinar, he's going to give a talk about linking coastal fisheries and environmental conditions to support integrated coastal management, PPGIS and structural equation modeling, and a structural equation modeling approach in Jakarta. So hello, Dr. Faizal, how are you?
Hello, Mas Tony. I'm good. Thank you.
Perfect. Are you ready to start the presentation?
Yes, of course.
Yeah, let's continue to our invited speakers. Dr. Faisal, the floor is yours.
Okay, thank you, Mas Tony, for your brief introduction about my background. Here, I will deliver a presentation related to integrated coastal management with title is linking coastal fisheries and environmental condition to support the integrated coastal management. And the lesson learned and the study case is from Jakarta. And I did this research with the approach of PPGIS or Participatory on Geographic Information System and structural equation modeling to identify about the correlation among the variables to ensure that this this variable is related each other. Okay, I will start to share my screen here. Okay, wait a moment. Okay, here is my screen. And as we know that the coastal area are increasingly facing complex pressures from rapid development and intensifying human activities, which directly affect both environmental condition and also the coastal fisheries. In this presentation, I will discuss how linking coastal fisheries and environmental condition using a public participatory geographic information system and the structural equation modeling approach that can support the integrated coastal management in Jakarta. Okay, here, this is the content of my presentation. First is about the introduction, and this chapter 2 about the materials and methods. And the chapter 3, this is the talk about the dynamics of coastal fisheries and coastal conditions, and its linkages with the coastal development in Jakarta coastal area. And chapter 4, here is the dynamic relationship among ecosystem services amidst the coastal development in Jakarta coastal area. And the chapter 5 is the synthesis and strategic implication for coastal fisheries management. And the last is the conclusion. This is the strategic implication for coastal fisheries. And here, as we know that the coastal area is highly dynamic environment, further intensified by human activities like as a development, urbanization, industry, and others. From the previous presentation from Dr. Howe that we know that the like aquaculture activity is affected the total mangrove area And here we will not directly connect, but it's like some correlation between the development in coastal area with the fisheries condition. And meanwhile, the coastal areas have a provider of ecosystem services, one of which is the fisheries resources. Therefore, it is important to understand how that a good governance can support the sustainability of fisheries resources. From this slide, you can see the pictures that there are many activities in the coastal area. First, maybe in the top left, it's like Polton, and the top right, it is identified as aquaculture activities. And the center of the picture here is like a flood in the coastal communities houses here. And the bottom left is like the mangrove deforestation, as talked about by Dr. How in Indonesia is, yeah, is the score is quite high. And also in the top right here is about the oil spills in the coastal area. Okay, this slide is presents the global fisheries production from 1990 to 2020. You can see that here is the consisting of capture fisheries and aquaculture. As you know that the traditional livelihoods like shrimp farming and small-scale fishing play a vital role in the economies of developing countries like in Indonesia, some in Thailand, and some in Vietnam also, where the many coastal communities depend heavily on the fisheries sector for the income. And in 2018, you can see that here the global fish production is reached about 178.9 million tons, with aquacultures that's contributing 49%, and the capture fisheries accounting for 51%. And then since the late 1990s, the growth is in fish supply has been primarily driven by the aquaculture, as capture fisheries production has remained relatively static. You can see that the light blue here, light blue color here, and also like some of the dark blue here is a capture fisheries production. And from this picture, we can see that the growth is quite relative or static. It's different with the aquaculture sectors. And next, we move to the issue and the challenges in the coastal area. Fisheries issue and challenge in the Jakarta coastal area. The issue first is decrease in fisheries resources due to increasing coastal development, urbanization, and also the industrialization. And what is the challenge? The condition in the Jakarta coastal area are affect the fisheries resources here. And from the simple diagram, you can see, and the left corner is the issue and the challenge. And the center here, this is the condition in the coastal area. That environmental degradation is happen. Deterioration of fisheries resources is happen. And then increase of coastal pollution is, this is a positively increase. And also decrease of water quality here. Also, some area, especially for the small scale of fishers, there are loss of fishing port, loss of fishing ground, and also decrease of coastal carrying capacity. So why in the right box here, we call as the dynamic of coastal fisheries. Yeah, the dynamic is just affected by some event that happen in the coastal area. And here you can see that in the top left is industrial area in the coastal area, and the top right is the top right is the luxurious houses in the coastal area, and it is already happening in the coastal area of Jakarta. Some we call as a Pantai Indah Kapuk. And the bottom left here is the aquaculture activity. You can see that some industrial area had impact, especially for negative impact to the aquaculture activity. And the bottom right here is the picture of the small scale coastal fisheries. You can see that in the back of the picture, there's like the bridge so high, but the bridge is like what I call here is make some adjustment to the fishing port here, for especially for the small scale fisheries. And then, according to the Marine and Fisheries Ministry of Indonesia, 6 million ton of fish production, or 80%, was produced by small
Yang ambil
scale
data
fisheries
besok siapa? Kabar
in the coastal area per
penafsiran.
year. And
Oh,
it will
jangan.
be a serious problem if there is no policy address. And the research objective of my study here is to integrate the GIS, PPGIS, and structural equation modeling to assess the linkage between coastal development impacts, fisheries ecosystem services, and environmental condition in support of integrated coastal management in Jakarta. So this research is like I call as the through the focus group discussion by the coastal community, especially for fishermen and also some stakeholders that they were in the coastal area. And the chapter 2 here is the material and methods. The study area is located in Jakarta Spatial Province, is capital city of Indonesia, as you know. Even as the capital city will be moved to IKN, but still in Jakarta, with total population is more than 10 million people in 2024, with total area is more than 600 kilometers squares that is located in Java Island, precisely located between West Java Province and Banten Province. Jakarta Special Province has 5 regencies. They are East Jakarta, North Jakarta, West Jakarta, South Jakarta, and Central Jakarta. Here, from the map, you can see that it's very populated. The red color is indicated built-up area. It's mean built-up area that made by the human, maybe is collect from houses and other public services. And you can see also here the green color indicated the green area that like the open space and also the yellow area is for the cropland. Yeah, some places in Jakarta still as the cropland. And then here is upon the data collection and the processing. Public participatory on GIS was employed to assess the coastal condition, and the findings were integrated with PLS SEM to examine the interrelationship among the established variables. And then we use the INVEST to evaluate ecosystem services encompassing the coastal blue carbon, nutrient delivery ratio, habitat quality, and also habitat risk assessment to determine the risk level. This approach aims to identifying the trade-offs and synergies among ecosystem services. An integration of spatial overlay analysis, zonal statistic, rate of change computation, and non-parametric correlation was utilized to investigate the spatio-temporal interaction among essential ecosystem services. And here is chapter 3. This is the dynamic of coastal fisheries and coastal conditions. And its linkage with the coastal development in Jakarta coastal area. The structure is to assess the dynamic of small-scale fisheries and coastal condition and its linking with coastal development. We use questionnaire to gather primary data on marine fishing activities, aquaculture, and also the coastal condition in Jakarta over 30 years periods with 80 respondents of fishermen. For your information, that I did this research is during the pandemic condition, so it's quite challenging how to collect the people, how to process, and how to like doing the focus group discussion is quite challenging. And next is the public participatory GIS. Yes, is to measure the dynamic coastal fishery like from 1990 to 2020. Also, we use the PLS or partial least square structural equation model to link dynamics of coastal fisheries and coastal condition with the coastal development. Here you can see that coastal fisheries in Jakarta, coastal area is consisted by marine aquaculture, also freshwater culture, marine culture, and brackish water culture. For marine capture, the vessel is for fishing divided into three types. Also, on the small scale, fishermen dominantly using the boat without the machine, and the number of boats less than 3 gross tonnage were fluctuated during year 2000 to 2020. In the first diagram, you can see this is like the total production of marine capture and fresh water culture. Yeah, the marine culture is quite high in the Jakarta coastal area, defending the aquaculture or freshwater culture. And then in the right diagram, this is the marine culture and brackish water culture. You can see also that the production of marine culture is higher than the brackish water culture. And also the last picture here is about the composition of vessels that used by the small, not small scale, but we can see that vessel more than 10 gross ton is quite high if we compare to the boat without the machine, because mostly the small scale fisheries is using the boat without the machine or less than 3 gross tons. And here this figure present the PPGIS map of Jakarta coast area from 1990 to 2020, and the maps produced by the respondents during the FGDs, and the focus is on the condition of fish pond, mangrove, industrial areas, and fishing grounds. Here you can see that the map is started from 1990 to 2020. First I want to show here to wait. I will try to annotate it. Yeah, you can see here, this is the yellow dot here. This indicated the fishing ground. In 1990, this so many fishing ground, but you can see in 1995 the fishing ground is lower or decreased than in 1990. And also for the comparison in 2015 here, the fishing ground is available only like 8 location or 8 stone, and yes, like the same in 2020. So from the information from the coastal community, that they said that the fishing ground is decreased during 1990 to 2020. Also here, the industrial area, you can see in 1990 there is not like so many industrial area, but you can see, for example, in 2005, here is the industrial area is increase, and also the mangrove area. Okay, here, this is my last slide. Sorry for the technical problem here. I mentioned before that here, so like the condition in the coastal area of Jakarta consists of fish pond, mangrove, industry, and also the fishing ground. Okay, I will move to the next slide. Here, to assess the coastal condition, we developed the 16 variables. It is consists of the coastal development, the change of water quality, fishing boat capacity, total of fishing gears, and so on until the fishing grounds distance. Its variable relates to aspect of the coastal condition as a experienced by fishermen. The results show that the variables fluctuated based on public perception and experiences. And these findings serve as a basis for further assessment of the coastal condition in Jakarta coastal area. So I put this total of 16 variables into the structural equation modeling to it reliability. First, spot the ecosystem condition. The Kronspach alpha is 0.8, and the second upon the fishing effort, and the third is upon the total catch, and the fourth the total income. And the table 2 is upon the research model measurement. This consists also from 4 variables, start from ecosystem condition until the total income. The reliability result of the questionnaire indicated a score over 0.7. Hence, this is affirming that its dependability. And the second is the research model validity was assessed utilizing a Forner-Lacal metric that a score exceeding 0.5. That's indicated the validity of the research model. And here, the total of 16 variables, we try to identify the correlation coefficient between each variable, that the correlation was greater than 0, that it's indicated that there was a positive correlation between the variables. For the example, in the table, that the symbol of ECO1, it's mean the coastal development. And the EFO1 is the fishing ground, and EFO1 is total fishing boat, and EFO2 is fishing boat capacity. Yeah, we can see here that ecosystem condition has correlation, a positive correlation with total income. And also ecosystem condition have a positive correlation with fishing effort. And also the ecosystem condition has a positive correlation with the total catch. Okay, and here the coastal fisheries are under significant pressures. Yeah, coastal fisheries are under significant pressure from intensive development along the Jakarta coastal area. And the second, and the persistent environmental degradation in Jakarta's coastal area, as emphasized in prior research, highlight the essential function of ecosystem services in supporting of coastal fisheries. The next, and the socioeconomic aspect of ecosystem services is crucial, since alteration affect the life of coastal community and their governing frameworks. And the next, the findings highlight the urgent need for an integrated multi-sectoral approach to regulating the extensive coastal development on Jakarta fisheries and ecosystem. Wait a moment. Okay, here the chapter 4 is discussing upon the dynamic relations among the ecosystem services amid the coastal development in Jakarta coastal area. And this chapter is further designed to provide the implication for evidence-based fisheries resource management and sustainable coastal development. And still using INVEST, that INVEST was employed to quantify the major ecosystem services. This is provisioning, regulating, and supporting services. And urbanization, coastal reclamation, and industrial expansion alter the trade-off and the synergies. We further explore the impact of land-use-land cover on coastal ecosystem services, particularly from the perspective of total risk assessment and ecosystem risk. Okay, here, first upon the provisioning service in Jakarta coastal area, fisheries serves as a crucial provisioning function, sustaining the livelihood of small-scale fisheries and enhancing the local food supply chains. And then the coastal fisheries, both marine capture and aquaculture significantly contribute to overall fisheries production in Jakarta. Yes, from this graph that you can see, the top production of capture fisheries production was happened in 2015, it is close to 3,100 tons. And also, the bottom one is the aquaculture production. You can see also the top production of aquaculture was happened in 2010, which is disrupting the ecological process, such as the coastal blue carbon. So you can see the legend here. The red color indicated the low coastal blue carbon, and then the close to the blue color, it means that this is like a high coastal blue carbon area. And here, I try also to assess the nitrogen surface export. In Jakarta coastal area, accelerated urbanization and industrial operation have resulted in extensive nutrient influx from sewage discharge and industrial waste. The nutrient level in Jakarta coastal area, particularly like phosphorus and the nitrogen, have significantly risen between 1990 to 2020. And the increase, largely driven by anthropogenic activities, has had a profound impact on marine ecosystems. Exhibits a generally stable geographical pattern with the incremental temporal variation. You can see from the maps that the I call as a pattern or variation is quite the same like for 30 years. And then the sustained phosphorus input can result in chronic eutrophication. It is potentially altering the productivity and species composition of coastal fisheries resources. And here is we also try to calculate the habitat quality maps. In here, the supporting surface, the degradation of mangrove and aquaculture ponds alongside the industrial expansion has both direct and indirect effects on coastal ecosystem services, especially those that sustain the small-scale fisheries. In this context, the habitat quality is a vital component of supporting services as it directly affects the ecosystem capacity to preserve biodiversity and uphold the ecological resilience. You can see maybe this model is quite same and quite familiar with the HGI index with the mangrove. I use also like the distance from the road, the distance from the industrial area, the distance from the fish ponds, like that. And here also we integrate the HRA model or habitat risk assessment of ecosystem services in Jakarta coastal area. HRA model in INVEST serves as an effective instrument for assessing the vulnerability of coastal ecosystems. Through two principal factors are evaluated. Four is the stressor and the habitats. Stressors are human-induced pressure that may harm or alter the natural environments. And then habitats are ecological elements that support the biodiversity and the ecosystem services. Also, we integrated the total risk assessment to know about the impacts or impacts of anthropogenic stressor. Here, the risk assessment offers an essential perspective for comprehending the effects of extensive coastal development. There are three categories was assessed. There are mangrove, aquaculture, and fishing ground. In 1990, you can see that fishing ground represent the most vulnerable category. But in year 2000, both aquaculture and mangrove category face the heightened risk level. And also, a significant turning point occurred in 2010 when mangroves exited the outer ecosystem in terms of exposure and the impacts. And by 2020, mangrove emerged as the most vital ecosystem under the threat, as the diagram indicates their highest level of exposure and the impact. And here we also assess the total risk ecosystem. The regions shaded in red denotes areas of elevated ecosystem risk, whereas the lighter set is signifying reduced risk level. In 1990 and 2000, high-risk areas were primarily located in coastal zones and river estuaries, indicating that substantial impact from coastal development, industrial activity, and depollution. By 2010 and 2020, this area expanded significantly. You can see here that particularly in reclaimed land and rapidly urbanizing coastal zones, indicating that intensified rates from urban expansion, land conversion, and declining the water quality. And here we try to summarize that spatial temporal relationship among the ecosystem services. The coastal development induced the trade-offs among fisheries, water quality, carbon sequestration, and nutrient management, that hence modifying the ecosystem services in several ways. This is a more comprehensive explanation of how this trade-off materials. For the first category, this aquaculture versus the water quality, the negative trade-off here is the coastal development frequently results in heightened pollution, sedimentation, and eutrophication. But the positive trade-off here that certain infrastructure projects such as artificial reef or marine protect area may augment fish habitat and boost the fisheries production. And the second category, this is the fisheries versus carbon sequestration. For the negative trade-off is a destruction of mangrove and the reclamation of coastal land diminish the carbon storage potential. And the positive trade-off here is integrating blue carbon protection, such as mangrove restoration with coastal development. And the third category here, water quality in relation to fisheries and nutrient regulation. And the negative trade-off is elevated nutrient concentration can induce algal bloom and hypoxia, adversely affecting the fish population. But in the positive trade-off here, that sustainable coastal management methods, including wetland protection and green infrastructure, may regulate the nutrient level. And the fourth category here is carbon sequestration against the coastal development. And the transformation of land for infrastructural and industrial purposes results in the decrease of carbon sequestering. And the positive trade-off here that are policies that advocate for natural-based solution can reduce the carbon loss while safeguarding the ecosystem services. And here, this is the quantitative relation among the ecosystem services. Some area have a synergy and some area have the trade-off. And here, the green legend means the synergies and the red means the trade-off. Yes, this is the summary here that its area framework assess the cumulative effect of these stresses on additional coastal habitats. And also the key finding in the is the establishment of trade-off between ecosystem services, wherein the economic and infrastructural growth frequently compromise the natural functioning. The primary factor influencing this trade-off are industrialization, governmental policy, and international commerce, which have favored economic expansion at the expense of ecological sustainability. And here, the Spearman rank correlation analysis revealed that moderately strong inverse link between trade-off and synergies, that indicating spatial competition between the two ecosystem service interaction. And the finding highlight that imperative for a cohesive coastal management approach that harmonizes economic, social, and environmental objective. This is the synthesis or application for coastal fisheries management. Yeah, as we know, this is like a general conclusion. And this is the static implication for coastal fisheries. First is the integrated coastal spatial planning. This is coastal land use change and high cumulative ecological risk call for stronger spatial planning regulation. This includes incorporating risk-based zoning and ecosystem consideration as supported by Indonesia's regulation. And the key actors include the Ministry of Marine Affairs and Fisheries, local government, and environmental agency, and the socio-ecological data integration. The spatial in transformation driver identified through the machine learning emphasizes the need to incorporate socio-economy factor into spatial plans and national development strategies. This aligns with the Indonesia's coastal regulation and FAO guideline on small-scale fisheries. The key actors, including MOMAF and rural development agencies, play central roles. And also, number 3 is the community-based co-management and participation. And the 4th is ecosystem restoration for fisheries resilience. Yes, I think that's all. I'm sorry for the technical problem here, and open to question answer, and I give to Mas Tony.
Yeah, thank you, Mas Dr. Faizal, for giving such informative and interesting presentation regarding coastal condition in Jakarta. And now we continue to the Q&A session. I really appreciate if the for the participants' engagement. Please, if you have any question, write them in the chat box, or you can ask directly to Mas Faizal. Any question?
Hi, yeah, a little bit questions from me.
Oh yeah, but
It's really nice talk that you gave to us. Thank you. And I just wondered about the shifted fishing ground movement. Is it going to the north? Because in the presentations, you're explaining that the fishing grounds is decreasing. And it is indicated from 1985 to just recent, right? Is it 2022 or 2025? I forgot about that. But how do you calculate that effort from the last time? Thank you.
Okay, Mbak Anes. Okay, let me share the screen about the fishing ground. Wait a moment. Oh, this one. Yeah. Okay, thank you, Mbak Anes. This data is from the fisherman's experience. So I just like make like a boundaries here. You can see it here. This is the boundaries that defined by the small scale fisheries. So maybe if the yellow dot maybe move to the north area is possible, but this area is like drawing by the fishermen that this their area to cap the fish is only in this area, and based on their assessment or based on their experience, is the fishing ground is more far, not like in 1990 or in 1995. In fact, in 2020, the area that they already catch the fish is, yeah, the fishing ground is a decrease. And I think it's that.
Thank you.
Okay.
thank you, Mbak Anes, for the question. Any other question? Okay, maybe while waiting for the question from the participant, I have a question, Mas Faisal.
Okay. Please.
Yeah, I see if the from the presentation, yeah, if the small fisheries scale is affected,
Mhm.
do they still doing the same activities presently? Maybe if you have any info.
Oh yeah.
Yeah.
Thank you, Mas Tony. Yeah, based
Mm,
on the research that some small scale fishers, they
mm,
like shifting their profession like in industrial area and also as a trader in the north of Jakarta. Because
mm,
you know in Pantai Indah Kapuk, yeah, in Pantai Indah Kapuk is like some construction sector that
mm,
was built over there. So some like fishermen is like shifting their profession. So like
mm,
for catch the fish is only like not the primary
mm.
jobs, but for the secondary or the tertiary job, not like the previous one. So they are shifting their job.
Oh yeah. Thank you. From the audience, please, if you have any question.
Okay, maybe
Oh yeah,
we have
Prof.
some
Alem.
questions. So, yeah, it is very interesting talk from Dr. Thuy and also Dr. Faizal. It is also very focused on the quality of the environment in the coastal area, I think, yeah. And then also many kind of the issue that is very, very close correlated to the social and economic condition of the society. So, uh, did you already have some evaluation how the impact of the decrease of the quality of the fishing ground, maybe the quality of the mangrove, and maybe also overall the quality of the environment to the society, and also in the term of social and economic condition, and how to minimize the negative impact and also how to maximize the positive impact, if any. Okay, thank you very much.
Okay, thank you, Prof. Alem. Yeah, until now, honestly, we still don't evaluate it in this condition because I like a study for to identify like the past of the 30 years and the fact that the fishing activity is decreased, especially like for the fishing ground, especially like the total area of mangrove activity or fish pond. So not mangrove activity, but the aquaculture activity is decreased during the 30 years. And until now, we still don't have any data to evaluate it or on the result of evaluation. But the next question is related how to minimize the impact. Yeah, the minimize the impact is maybe we already know that I get lesson learned from the Xiamen case that the government is like Hanover. The government to Hanover to the society that they relocated, yeah, they relocated like the fishing activity. For example, in Xiamen that they move some cages, move some aquaculture activity to the another area. But in Jakarta here, it's quite complex because sometimes the policy or the political issue still stand alone. That they don't think about how to sustain the small scale fisheries. Yeah, in my mind, that how to minimize the impact is the government must be like hand over this issue so they can think how to sustain the small scale fisheries activity in the North Jakarta. For example, based on the Jakarta government is planning that they will build the seawalls, that it's also have a positive and negative. But in my mind, it will give more negative impacts, especially for the ecosystem or ecology in the North Jakarta. But it has a positive impact with the like the housing, like to prevent from the flood or the like operation in Jakarta. So it's like I call in this research as a trade-off. Someone is something can decrease, but in the other side it will be increase. It's as like the trade-off. But I think it's yeah, it's quite interesting to do more research about this area. So why I deliver this to in the term of and topic of integrated coastal management. Yeah, honestly, I don't have any idea how to facing this political issue and yes, many aspects that must be thinking in the North Jakarta. I think that's a professor.
Okay, thank you, Dr. Faizal. And maybe any comment from the side of Dr. Hua, is any experience from Vietnam maybe to manage the coastal area and also how to minimize the negative impact and also how to maximize the positive impact. Thank you.
Thank you for the question, Prof. Alim. Yeah, maybe Dr. How do you have any opinion regarding the topic?
Actually, I didn't have much practical experience regarding solving these kind of issues. What I have is just the lessons from Xiamen universities these years, and what I have experienced from Xiamen University. So, in my opinion, for effective management, it should have the good coordination between different stakeholders in that area. And the one of the key of is the government. So first, the government should put a high position of these problems onto the agenda, because for example in Vietnam these days our priorities are a little bit more on the economic activities development rather than protecting the impact on the environment. So actually this has to be more emphasized into the agenda. It is the first condition, in my opinion, because compared to some other countries like China, China is also an emerging economic country, but the government has spent quite attention into the environmental problem. So in China, for example, they will have the quite good coordination between academic institute with the government. So the government work with the research institute to provide the insights for how to coordinate and spatial plan the region. So for example, they will have some kind of provincial projects that the government wants to know what is best to allocate, what is best to invest or fund. And then they work with the research institute. And then after that, they will have some kind of promotion and some kind of campaigns and continuous campaign to raise the awareness for the local people as well. And very important point is the willingness to coordinate with the government from the local people and the willingness to take actions from the government. I think we as researchers, we can contribute a lot to these to this problem by contributing to the insight and continuously encouraging and promoting the awareness to put it to higher position in the agenda. And yeah, that's my opinion. Thank you.
Yeah, thank you. Wonderful,
Thank you.
Dr. How, for your insights.
Yeah.
Mas Faisal, I see some question coming in the chat box. Yeah, the first one from Pak Propo. What's your opinion about the prediction of future conditions for fisheries activities, about both aquaculture and capture fisheries due to land subsidence, rising sea levels, and the construction of artificial island in the coastal areas of Jakarta?
Okay, thank you, Pak Probo. Yes, nice question. First, I see this question is on the impact of or the prediction, the condition of fisheries activities. If I say here about the land subsidence, rising sea levels, and the construction of artificial island in the coastal area of Jakarta, the main impact I think is from the artificial islands development in north coastal of Jakarta. Because like for the land subsidence also in some fact that it's affected by the mining of or not mining but exploitation of groundwater is impacted to the land subsidence, and also from the fact that some building in the north of Jakarta, there are some in the construction there are some the cracking in the construction. It indicated that the ground is getting lower or subsidence. And about the sea levels, yeah, sea level is I think is generated from the natural activity. So we don't have any like evidence how it's happened. But the main problem that impacted on the fishery activity, I think, is from the artificial island, because the artificial island just like destroying the habitat, underwater habitat, especially like the coral reef and something else in the bed of seafloor. I think that's Mas Tony. I also see in here a question in chat box from Amalina from
Yeah,
Semarang.
yes,
Yeah.
it's almost the same. Yeah, you can
Mhm.
maybe you
Yeah,
can
notice
give your opinion. Yeah.
yeah, total risk ecosystem. Mhm. Yeah, if maybe I can say that in the condition in North Jakarta and also in Semarang is quite similar, because it's also located in Java Island, the same island. The trend, in my opinion, it will be the same problem, and same condition will happen in Semarang. Yeah, some like mangrove maybe or aquaculture activity, it will be destroy or in the top of habitat risk. I think that yes, it will be the same in Semarang. And
Yes,
also here,
perfect. Yeah, I think the last question, Mas
ah,
Faisal. Yeah,
okay.
how do variations in water quality parameters, such as temperature, salinity, and dissolved oxygen, nutrients, affect coastal fish abundance and diversity?
Yes, of course. The variation of like this parameter is influence the abundance of fish and fish diversity. Because in the oceanographic sector, we also study about this, that some temperature maybe or salinity and also DO and also nutrient will affect the abundance and diversity of coastal fish and fisheries. There, I think like for example, in my research, I did some research related to the pollution. It's come from the industrial area. It just like impact the salinity, impacting the total dissolved oxygen. So maybe the pollutant from the industrial area will decrease the number of total dissolved oxygen. Also, some area this increase the temperature in the coastal water, and it has impact in the coastal fish abundance and diversity. Yeah, I think so, Mas Tony.
Yeah, well, because our time is limited and we have to end this SinnTech webinar session for today. We have covered vital strategies for integrated coastal management. Key takeaways include: first, we need to protect mangrove ecosystem in Southeast Asia, as existing intact mangroves are becoming scarce. And the second, coastal development in Jakarta in Jakarta needs a multi-sectoral approach. Yeah, I thank the invited speakers, Dr. Hao and Dr. Faisal, for sharing the knowledge for the interesting presentations and discussions. I hope to see you again in another occasion. Wish you all the best and thank you for all participants. I hope to see you again in the next SinnTech webinar. Have a good afternoon, everyone. Yeah, thank you.
Thank
Thank
you.
you. Oh, thank you very much.
Thank you for
Yeah,
all.
I hand over to the MC.
Okay, thank you to Mr. Tony for your successfully moderating the session. Okay, the next agenda, it is the awarding of certificate to our speakers, and it is a moderator by Professor Dr. Insinyur Alim Isnan Setio M.Sc. To the assigned operator, please share the screen.
Okay, in this the special occasional, I would like to thank to Dr. Ngo Chu Hao for the nice talk and also very comprehensive talk, how to manage the coastal area. And I would like to deliver our small certificate of your talk from our Department of Fisheries, Universitas Gadjah Mada. Please receive the certificate.
Thank you, Professor.
Thank you, Prof. Alim.
Yeah. Yeah, also for Dr. Faizal, a great talk in this afternoon. So for the certificate, please also receive from the Department of Fisheries, UGM.
Yes, thank you, Professor.
Okay, thank you very much to Professor Dr. Insinyur Ali Usnans, the M.Sc. Before we conclude today's event, we will have a group photo session. We kindly request all participation to turn on their cameras and share their best smiles. I will now count down from 3 to 1. Okay, please open your cameras to all the distinguished participation.
Yeah, please.
Okay. Okay. For the operator, please
Yeah.
jump the screen. Okay. The first slide, I will now count 1, 2, 3. And then the next slide. Okay. And then the last slide. Okay. Thank you. Okay.
Thank
Ladies,
you.
thank you.
Thank you, Dr. Hoa. So please keep in touch with us to make some kind of other academic and also maybe also research activity with us to improve our collaboration with your institution.
Thank you very much, Professor. And hopefully we will have more chances for more collaboration and academic exchange in the future.
Yes, yes.
Yeah.
Thank you much.
Yeah. Thank you very much.
Yeah. See you. Good luck.
Okay, ladies and gentlemen, we now reach the end of the SinnTech 33rd webinar. On behalf of the organizing committee, I would like to extend our sincere appreciation to our speakers, moderator, and all participation for your valuable contribution and active participation. We would also like to kindly remind all participation to complete at the attendance form that has been shared by the operator in the chat box. We hope also the knowledge and insight shared today will be beneficial for your future academic and professional endeavors. I'm Ilma, as the Master of Ceremony today. I'm apologize for any inconvenience or shortcomings during of the course of the event. Thank you for your attention and participation. We look forward to the welcoming you again at the next SinnTech webinar. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Warahmatullahi wabarakatuh.
Okay, thank you, everyone. Bye-bye.
Okay, thank you.
Bye.
See you next month in the next webinar.